let's explore a function that uses recursion and a number parameter. So here we have a sum function. Its purpose is going to be to add up all of the positive numbers between 1 and the n parameter that is provided. This is a function that takes a single parameter and will return to us a number when it's done computing. The first important rule to remember when we're writing a recursive function is that it must have a base case. It must stop at some point. Typically, or most commonly when we are iterating using recursion and a number parameter, we will set the base case to be when that number is equal to 0. That's when we will stop recurring. We will stop recurring when we hit this base case. And the base case is simply going to return 0. The recursive case then is when we have a non-zero number, so imagine 1, 2, or 3, we will return n, the current n value, added to the recursive call here. So here sum is calling itself recursively. But notice something important is happening here in the argument. We are subtracting 1 from the argument that this function call was made with. So if n were 3 when sum was called initially, sum is going to call itself again, but with 2 the second time around. And that's important because we are changing an argument, which is this second important rule about writing a recursive function, and we are bringing that argument closer to the base case. We're bringing n closer and closer to 0, assuming that n were positive. This is what we call the recursive case. And we will explore how this function runs with a simple tracing of it and an example that we'll see down below. So down below we can see a main function, and this main function is pretty straightforward. It has 2 statements in it, an assignment statement and a print statement. We can see that the program is going to start by calling the main function, so let's imagine that we are going to begin our tracing of this program right here at let y be a number. In order to trace this function, I'm going to set up a separate side of this screen to illustrate what is happening in our code. So let's imagine now that we are in the main function. This is the name of the function we are currently working in. And the computer, for its part, is going to care about 2 things. What is the current line that it's trying to execute? So the current line that the computer is trying to execute is this one here. Let y be a number variable that is assigned an initial value of the result of calling sum with an argument of 2. And I'm going to set up another side of this for my memory or my stack. Right? So this is all of the variables that each of these functions is going to have stored in it. Right? So we call this our stack, and we won't get into the details of that in this video, but the important thing to note is that right here we are going to see the current line of code that the computer is focused on trying to resolve down to a single result, or to complete, to run through and through. And we know that because this is where we are at in our program. So this is a variable declaration statement. It is setting up a variable named y in memory, and it is trying to assign to y the result of calling the sum function with an argument of 2. In order to know what this expression is going to evaluate to, we must first go call that function. So what are we going to do? Well, we're going to drop a bookmark right here. We're going to say we're going to come back to this point, but we're going to need to jump into the sum function to go figure out how what its result will be when it's called with a value of 2. So when a function call occurs, and we know that this is a function call because it's a function name followed by some parentheses and some values inside of those parentheses. Here it's the value 2. We are going to set up and say, all right, well, we're going to leave main for a second, and we're about to go into the sum function. All right? And before we go into the sum function, we need to pass this argument 2 and assign it to the parameter n. So it's as if we had written in our code, n is assigned 2. So we know that parameters are just special variables that are automatically set up for us on our behalf when we call a function. So here we're saying n has been assigned to 2. Now we need to see, well, what is the line of code that we're going to evaluate in the sum function? That line of code is if n is equal to 0. So the computer, before it knows whether to go into the then block or the else block, it needs to evaluate whether or not this line of code is in fact true, or this expression that our if statement is testing is true. So how does the computer evaluate this? Well, first it needs to look up what is n. For the purposes of this function call, n is 2, so it's going to substitute 2 here. Then we're going to ask, is 2 equal to 0? That expression is going to resolve to false. Now, when an if statement resolves to false, what do? Well, let's go look at our code again. And our code is going to not go into the then block. We're going to skip over that. We're going to go to the else block. So now, inside of the sum function, the line of code that we are trying to figure out what is the answer to is this return statement. So return n plus sum of n minus 1. So now we need to resolve what is this expression. Well, we can substitute for n. N is 2, and 2 here. We have an arithmetic expression, 2 minus 1. We know that that is going to be 1. And now we see we have a function call that we need to go figure out. What is the resolution of, or the evaluation of sum called with an argument of 1? Well, once again, we're going to drop a bookmark. And I should have maybe noted that this was sum of 2 here when we called it, right? So this was when we called sum with an argument of 2. That came from this point in our main function. And so now inside of sum of 2, we are calling sum recursively, this time with sum of 1. So I'm going to go ahead and set up what happens when we call sum of 1. And once again, we've got some space. And we know that the first thing that happens when we call a function is we have to assign this argument, which is 1, to our parameter n. Remember, this process is like saying assign n a value of 1. So this call to sum of 1 has its own copy of an n variable, right? So the n when we call sum of 1 is 1. The n when we called sum of 2 was 2. And everything's fine and happy here. And so the next thing that we're going to do is jump in and start back from the top. All right, so we need to evaluate if n is equal to 0. Well, let's go ahead and say that this is the line the computer needs to evaluate. So it's going to work through this line just the same way it did before. Right? It can only work on one line at a time, and this is where we are in our execution of this program. So now we need to see, what is n's value? Well, n's value for the purposes of sum of 1 is 1. And now we're going to ask, is 1 equal to 0? That is false. Right? So this statement has been evaluated down to if false. Well, what do we do if we have an if false in our code? Well, the computer is going to skip over the then block, and the next thing it's going to try and evaluate is this return n plus sum of n minus 1. So the line of code that the computer will be focused on now is return n plus sum of n minus 1. And here, let's go ahead and substitute for n. So n for this function call is 1. Sum of n minus 1 is 1 minus 1. And so 1 minus 1 can be simplified to 0. Well, once again, we have a function call which we must figure out the evaluation of. So we're going to place a bookmark here. We've got to come back to here. And we are going to call sum of 0 and go figure out what its evaluation is. So sum of 0 is going to happen. And when we call a function, we know that we're going to take this argument and assign it to the parameter that it corresponds to. So n is going to be assigned 0. That means in memory, for sum of 0, n will be 0. And we go to the top of this sum function for sum of 0. And here we're saying if n is equal to 0. Well, we need to substitute for n. N is 0. And then we're going to ask ourselves, is 0 equal to 0? That is true, right? 0 is equal to 0, so this is true. We know that when we have an if true statement, we need to go into the then block. And so the next line of code that the computer is going to evaluate is this one, right? We're not going to go to the else this time around. We're going to the base case. And we need to evaluate return 0. Right? So when we hit a return statement and we have evaluated the return expression down to a single value, here that single value is 0, we are saying, all right, well, wherever we left that bookmark, wherever sum 0 was, we need to take 0 and replace sum 0 with that, right? Well, where was our bookmark? We're going to take this, and our bookmark was here, right? So we are going to evaluate sum of 0 here to no longer be sum of 0, but we're going to replace this with the value 0. You can see this being traced, right? So our return statement said, all right, the result of calling sum 0 was 0, so wherever this was called and wherever we left that bookmark, replace it with that value. Once this replacement has happened, we can effectively return back down to sum of 1. We don't need to know anything about sum of 0 anymore. We can leave that function. And now we are back at return 1 plus 0 when we were calling sum of 1. We need to evaluate what is 1 plus 0. Well, that's pretty easy. That's just 1. And now we have another return statement whose expression is a single value. And so we're going to take that single value and say wherever we left the bookmark where we called sum of 1, which was down here, we are going to replace sum of 1 with this return value. So that return value is just 1. And so that gets replaced here. Right? So now that we have returned back to sum of 2, we can once again remove the work that we did to figure out what sum of 1 was. And now we are back in sum of 2, and the line that we were working on is return 2 plus 1. Well, we know that 2 plus 1 is 3. And once again, we have evaluated our return expression down to a single value, 3. And so we can say wherever we called sum of 2, we're going to replace it with 3. So where did we call sum of 2? We called it back in main, right? So this is where we called sum of 2. So we're about to be back in the main function. And how do we do this step? Well, we take this return value, and where we called sum of 2, we replace it with that return value. So sum of 2 is no longer sum of 2. It is evaluated to 3 by the machine. Notice that you never see these steps happen. In code, your code is always going to look like this. But what the computer is doing is it's working through your code in this manner. So now that we've returned this value and substituted, well, what was sum of 2, we can get rid of our work for figuring out sum of 2. And finally, we are back in the main function, and we have this value 3 being assigned to our variable y that was set up. So we can assign 3 to y, right? And this is the line that we left the main function from, and so we need to, now that we've finished up that variable declaration and initialization statement, we need to continue on to the very next line. What's the next line? It is print y. So in main, the next line that the computer is going to evaluate is this function call to the special print function, print y. Well, the computer doesn't know what y is, so it needs to go look it up. Y is currently 3, and so 3 will be sent as an argument to the print function. And this is what's going to cause 3 to print to the screen, and you'll see it show up in your web browser. Once that print function call is completed, main has reached its endpoint, and our program is actually done. We've terminated because there's nothing left for us to do. And so this is how you would trace through a recursive function that uses a number parameter.